on the coordinate plane.
Start the video with
Whew. All right. A rotation turns a figure around a fixed point called the center of rotation. Right?
Miss Mars,
Yes.
how many subscribers do you have?
I don't know.
Why would you
Not enough to brag about it, that's for sure.
One.
You should be
Probably have,
52
like, 4.
subscribers.
4 subscribers.
Everybody make 10 accounts and subscribe.
Okay. So when we're talking about the center of rotation, think of like a bike tire and like how all the spokes come together in the middle. That would be the center of the rotation, right? For our examples, the center of rotation will be the origin and will rotate in increments of 90 degrees. We're going to pay attention to the direction of the rotational. We have clockwise and we have counterclockwise. For those of you that don't like to use circle, like these analog clocks, this is the way the hands and the seconds move on a clock. This is the opposite. So counter is meaning opposite.
Now let's just I just randomly have this question now. What came first, the terms counterclockwise or clockwise, or actual analog clocks? Random question.
I don't know, Nick, but I got to get through my video. So let's move on. Okay. All right. So we've got a starting point here. If we're moving clockwise, if we moved 90 degrees, the image would be here from our pre-image. If we moved 180 degrees, we'd be here. And if we rotated 270 degrees, we would be up in this quadrant. Okay? And it's really important because when you see something shift, you want to be able to tell, like, how far did it go? Yes, sir.
Is it divided in 4 quadrants?
Sure is. I'm sorry?
Like a,
Yep. Absolutely.
Well,
Yep.
on a graph.
So everything would start in one quadrant and end in the other. Okay? Right? So if I started over here, this would be 90 counter, 180, and 270 counter. Right? So let's evaluate some of these. Let's look here at this pentagon. We have A and A prime. So what rotation did it make clockwise? How many degrees? It just went 1, so that's a 90-degree rotation. What about counterclockwise? If it had gone this way, how many?
270.
270. You guys got it. So this is 90 degrees, and we're just going to use CW for clockwise, or 270 degrees counterclockwise. If I connect those two arrows, what do I get? 360. So if it moved 360 degrees, it would be in the exact same location, right? All right, how about B to B prime? How did we rotate clockwise?
270.
270, and then 90 counterclockwise. That looks like 900. Let me fix that.
Why did you say you hit?
You'll see in a minute. Okay, how about C and C prime?
180.
Yep. Oftentimes they don't classify those as clock or counterclockwise because it's the same distance, so they won't really specify. All right, try 4, 5, and 6 by yourselves. I'm going to freeze the screen. Our at-home viewers will still be able to see what I'm doing, but you guys won't.
You didn't tell me to pause the video.
Pause the video. Too late.
Yeah.
Now they're just counting.
That's all right. I'm pretty sure that's what people do anyway. I'm not sad about it.
Literally pauses the video.
Oh no, Nick, not you apparently.
Yeah.
Nick doesn't watch
He probably does. Okay, check your work.
I got that right, but I just did it the wrong way.
How'd you guys do?
I put 19 at the top.
So this one went 270 because it moved 3 places. This moved 2 places, that's 180. And this only moved 90 degrees.
So usually if it's 90 on one of them, it's 270 on the other.
Sure is. Yep. Yep.
Yes.
Good connection.
Great job, too.
Okay, here we go to the fun part.
When you say fun
I
for
don't
you,
mean fun for real.
This doesn't.
according to
Mark,
you.
why don't you like this?
It's just, it requires a lot of focus, and it's very easy to get it confused, especially when we get to this point. So I think you guys are good at just looking at the shape, but when you have to actually create the rotation, that's where it gets a little messy. All right, so what they want us to do here is rotate these figures, then write down, we're gonna do it the backwards way. We're gonna talk about how to get the new ordered pairs so then you can plot them. When you're doing rotations, I'm going to highly suggest you figure out what your new ordered pairs are and then you plot them. If you try to plot them first, you're going to just give yourself a headache because a lot of us can't, air quotes, see that. Okay, it's kind of hard to spatially move it. So I'm going to tell you guys what the algebraic representation is. We're going to change the ordered pairs, then we're going to plot them. Sound good? All right, so if I'm doing a 90 degrees clockwise rotation, if I start out with X and Y as my pre-image ordered pair, my image will end up where the Y value is now my X, and the X is now the Y and opposite. Okay, so I flip-flopped them, and then the X is now opposite. So who thinks they can tell me what this A prime will be? 1, -2. Yep, I flipped them, and then the 2 became the opposite, which is going to be negative. How about B prime?
1, -6.
1, -6, and C prime? 7, -4. So then we will go up here to our coordinate plane, and we will plot those over 1 down 2, so that gives me my A prime. Over 1 down 6, that gives me my B prime. And then over 7 down 4, that gives me my C prime. And then I get this beautiful rotated triangular image. So now I'm going to show you guys something really cool, because you're probably thinking, like, why does it 90, 180, 270, like, where did those numbers come from? Are you ready?
Yeah.
Okay, so I want you guys to look up here and be ready for like a mini, like, oh my gosh moment. Okay, if I draw a line from my pre-image A to the origin, and then I draw a line from my image A to the origin,
Oh my gosh.
what angle do I get?
A triangle.
Whoa.
What angle does that make?
A triangle.
A 180. I don't know. It's fine.
Carlos?
A slight 90 degree.
A 90-degree angle.
A triangle.
Do you guys see what just happened?
Yeah.
No.
So that made it like those 2 points, when I connect them through my point of rotation, that should make a 90-degree angle,
So is this the shortcut?
is what the shortcut.
I would just say
This or this.
A 90-degree angle.
That's just so you guys know where the 90 comes from, right? Because some people are like, what does 90 degrees have to do with anything? Well, we create a 90-degree angle from our pre-image to our image point. So if I were to make 180 degrees, what do you think it's going to be?
Just straight
A
down.
straight line.
across.
Yep.
So technically it is a shortcut.
If you can visualize it, yeah. So even if I do C to the origin and then over to C, that's going to make a 90-degree angle also. And B to the origin and down to B, that's also going to make a 90-degree angle. So all of the pre-image points through the origin to the image points should make 90 degrees because I'm doing a 90-degree rotation, right? Okay, so in our own words, let's describe what happened here. We flipped the X and Y. X became opposite. Remember, we use the word opposite because if it was positive, we would make it negative. So we, instead of saying negative, we say opposite. Okay, 180 degrees is super easy. Algebraic expression. XY becomes opposite x, opposite y. You don't even change places. So what will be my a prime?
-2, -1.
Yep. What will be my b prime?
-6, -1.
And c prime? Yep. So now when I plot those, I get my a prime, b prime, and c prime. And if I connect my a to my a prime through the origin, I get a straight line. That's the 180 degrees. So that was 180 from my original pre-image. So what will we say in our own words?
X and Y became the opposite.
X and Y both became opposite. Okay, now for 270 clockwise, also known as 90 counterclockwise, our algebraic representation, you flip them, and this time the y becomes the opposite. So I'm going to have -1, 2, -1, 6, and -7, 4. Okay, so let's go ahead and look down here at 8, 9, and 10. They give us the algebraic representation between x and x prime. We need to figure out what rotation did they do. So based on our algebraic representation of the rules, what took place for x to get to x prime? What kind of rotation?
90 degrees.
Good job. Or you could take, say, 270 degrees counterclockwise, CCW. All right, how about for number 9? What took place here?
270 degrees clockwise,
Or 90 degrees counterclockwise. And the last one, we could just say 180 degrees. You don't have to classify because it's the same clockwise or counterclockwise. Do rotations preserve or change the orientation of the figure? They definitely change the orientation, but we preserve the vertices, right? The vertices are still going in ABC order clockwise, no matter how we rotate it. Or, excuse me, counterclockwise, no matter how we rotate it.
What is that row 44 in the bubble?
That's how many days are until summer.
Wow.
That's weekends and everything.
Oh.
That's it.
Really?
Yep.
Do we
But it's so
So what is it without weekends?
Oh, I don't know. Like, I count them so that when I come in on Mondays, I get to like subtract a couple extra days. It feels pretty good. Plus, without weekends, it's kind of deceiving. Okay, let's look at this last page. We'll do some of these together. We won't finish them, and that's okay. We have this rectangle ABCD. They want us to find the new ordered pair after a specific pre-image point is rotated. So find A prime after A is rotated 90 degrees clockwise. Well, A is at 2, 7. So A prime, based on our rules, would be at 7, -2. And then we look down here to this little code at the bottom, and we see that 7, -2 is with the letter A. So anywhere we see the number 1, we write the letter A at the bottom. All right. B is at 7, 7. And they want us to rotate it 270 degrees clockwise. So what's that going to be?
So negative 7.
7.
Yep. We flip them, and then Y becomes the opposite. But flipping them is kind of deceiving because they're the same, right? And that's actually going to be an N. So anywhere I see the number 2 at the bottom, I put an N. C is at 7, 1, and they want us to rotate it at 180 degrees. So that's pretty easy. -7, -1, because we just do the opposites, right? That's an O.
What letters do you use the first one? Or numbers in
There is no bug. Oh, I mean, I don't know.
That looks like a donut. Looks like I drew a donut.
What was the, what did you write down for the first? Write down the.
So for the number 1, I put an A. For the number 2, I put an N. And for the number 3, I put a 0, an O, the letter O.
Down here.
Yeah, so I just put the letters where they fall for the numbers that we've done. I'm getting the code over here. Okay, I'm going to stop there because I want to make sure to give you this orange paper. I haven't decided if I'm going to have you do it yet or tomorrow or not. But if I am, I want you to be prepared.
We have, I don't know this week. I don't want to
Let's go. Be prepared. Exciting. Yeah. Thank you guys for doing such a good job. Like I said, not my favorite thing to teach, but it always helps when you guys work hard at it. Did everybody get an orange paper? Landon, did you get one? Okay. All right. Stop my video here.